Hi there, this is Mr. Thill with another math video. Today we're going to begin looking at the properties of multiplication. Now in third grade we introduced and discussed three properties of multiplication. There's a commutative property, the associative property, and the distributive property. Now when I say property of multiplication, it's basically a rule that is true for all multiplication problems. So these properties or rules are true for problems like 7 times 2, but they're also true for problems like 25 times 584. So they're basically rules or properties that let us do things like move factors around, change groupings of factors, or break factors apart into new groupings. So today we're going to focus on the first and most basic of the properties. That is the commutative property. So the commutative property is essentially a property that allows you, when you're looking at a multiplication problem, to change the order of your factors without changing the product itself. So to illustrate that, we're going to look at the property through a mathematical multiplication problem, an array model of multiplication, and also the equal group model of multiplication. So let's begin by looking at it mathematically. Commutative property basically says that if 3 times 4 equals 12, I can switch my factors, and 4 times 3 will also equal 12. So I'm changing the order of my factors, but my product stays the same. To further explore this and to prove this property is actually true, let's go ahead and model these two problems visually with an array. So my first one, 3 times 4, will be read as 3 groups of 4. So I'm going to draw 3 groups of 4. Remember, you get rows and columns. Your rows are your groups, and your columns are the number of groups. So this would be 3 groups of 4. Now, if I count the number of objects in my array, I should get the same product as I got mathematically. So 4, 8, and 12. Now, commutative property says that I can actually take this array and then change the order of my factors. The size of my group can become my number of groups, and my number of groups can become the size of each group. So 3 groups of 4 can become 4 groups of 3. Now, based on the commutative property, when I model this as an array, I should have the same product or number of objects in the array. So let's see, 4 groups of 3. So there's 1 group of 3, 2 groups of 3, 3 groups of 3, and there's my 4 groups of 3. So if I count up my objects here, I should have the same product as I had over here. It should be a 12. So 3, 6, 9, 12. One more thing to notice is that when you look at these two arrays, all you're really doing is taking an array and rotating it to make the other array. So 4 groups of 3 becomes 3 groups of 4 when you rotate it. That's the best way of seeing that when you apply commutative property, the number of objects will not change, just the appearance of the problem or the size of the group. Let's look at it one more way. Let's look at it using an equal group model. So we'll go ahead and model the same problem using equal groups. So 3 groups of 4 would be 3 groups, and then each group will have 4 objects in it. And once again, just like in my array model, in my mathematical model, the product or total objects should be a 12. So 4, 8, and 12. And to illustrate commutative property, let's go ahead and model the flipped factor form of it, where we do 4 groups of 3. So I'll draw 4 groups. Then each group will have 3. And because commutative property says this is a law of multiplication, and because we can see it visually, we can now know that when we change our factors around, the product will stay the same, because we still have 12 objects in it. Now, when you're doing just simple 2-digit multiplication, does it really make a lot of sense to apply the commutative property? It's helpful when you're trying to memorize your fact families, and it helps you remember that if you have your 2's memorized, you can apply those to your higher values. Like 2 times 8 is the same product as 8 times 2. But when it comes to problem solving, it's more useful when we have 3-digit multiplication. For example, if I had a problem like this, 2 times 6 times 5, it might be tricky for some people to realize that 2 times 6 is 12, and then 12 times 5 is 60. That last step, they're multiplying 12 times 5, might be a little tricky. So commutative property is really useful because you can actually take these 3 factors and order them however you want. You could rewrite it as 2 times 5, then times 6, or as 5 times 6, then times 2, or any other order of the 3 factors themselves. And then it's a little bit easier to see that 2 times 5 is 10, and then 10 times 6 would be 60. It'll just be easier to solve in your head. So that's a brief overview of commutative property and when you can apply it, and also proof that when you do change your factors in multiplication, the product is still the same. So that's commutative property. Until next time, this is Mr. Thill.